All right, hello and welcome. So today what we're going to do is talk about division of polynomials. So if you remember in a previous video, we talked about multiplying polynomials, and I showed you how to use the box method to basically keep everything organized and logical in a visual sense. So in this lesson, we're basically going to follow that same procedure, but since we're dividing, we're going to kind of work everything backwards from the box method. So the way that this is going to work is I'm going to take the um, like the smaller of the two parentheses, the smaller set. So in this case, the 5x plus 6. And I'm going to put that outside of my box going vertically. And then what I'm going to do is take my larger set, or the one with the highest exponent, and I'm going to one by one put those values in the box. So I'm going to start with whichever x has the highest power, so 5x cubed. And I'm basically going to work my box as if I'm solving a puzzle one bit at a time. So if I see a 5x next to a 5x cubed, that tells me that I'm missing an x squared, because x squared times x gives me x cubed. I don't need any extra numbers because 5 times 1 would keep the 5. So the next thing I know is that when I'm doing a box method, the numbers on the side multiply with the numbers on the top to fill in the inside. So 6x squared would be this position right here. If I look at the set that I'm given, I see an 11x squared. So what that tells me is that I am missing 5x squared, because together I need 11x squared. So basically now I'm going to kind of repeat that process until I've filled in my box. So I have a 5x squared in the top row and a 5x on the outside. So what I'm missing on the top is an x, because x times x gives me x squared. I know that to fill in the box, my 6 would need to multiply with my x, so I should see a plus 6x here. In my original problem, I see a 26x, so that means I am missing 20x. So if I compare 5x with 20x, I need to multiply by a 4, because 4 times 5 gives me 20. And then finally, 6 times 4 gives me 24. And now I'm all out of x's, so my box is complete. So the last bit is to compare the number I ended with the number I'm supposed to end with. So since I ended on 24 inside the box, and I have 26 in my original polynomial, that means I am missing an extra plus 2 to the outside. This plus 2 is my remainder. And so when I'm writing my remainder, I always write it as a fraction with whatever I was dividing by. So my final answer is going to be whatever is on top of the box plus the remainder. In our second example, I want you to notice that the variables were written out of order, right? So last time we had the highest powers going first. This time it's all mixed up. So when I set up my box, I'm still going to use the smaller set first, but to keep everything organized, I want my variable to be the first thing that I write. So I need a 3a and then a minus 3. And so when I start filling in my box, I always want to find the one with the biggest power. So I'm going to start with this 3 right here. So I've got my 3a cubed on the inside, and now I'm going to start working my puzzle. So if I see 3a cubed on the inside and 3a next to it, the only thing that I'm missing is a squared. And then I know that negative 3 times a squared gives me minus 3a squared. So what I need to do is figure out where the a squared is in my original set. So I see a 6a squared. I'm given a negative 3a squared. So I need to add 9 because 9 minus 3 would give me 6. And so if you are confused about where the 9 came from, what I'm doing is taking the number that they gave me, which in this case would be 6, and I am subtracting what I see in the box. So minus minus makes a plus, which means I'm missing a 9. So that's where the 9 came from. So now we're just going to kind of fill in from there. So if I see a 9a squared, right, I need a 3 up here because 3 times 3 gives me 9. I need another a because a times a gives me a squared. For the bottom row, negative 3 on the outside times positive 3 from the top gives me a minus 9a. So I notice there's a minus 18a over here. So if I'm confused as to what I'm missing, the minus 18 is what I have, minus 9, because the minus 9 was in the parentheses or inside the box. So this is another negative 9. So I need another minus 9a. So I see a 3a on the left, a negative 9a in the middle. So I need another negative 3 on top because 3 times 3 gives me negative 9. And then I don't need any more a's because the a's already match up. And so for my last bit, negative 3 times negative 3 is positive 9. I'm out of variables, so my box is closed. And then finally, the plus 9 here matches the plus 9 here, so I actually don't need a remainder for this. So to write my final answer, since I don't have any remainders, I'm just going to copy down what I see on the top of the box. So my answer is a squared plus 3a minus 3. That's all we have for this one. I will see you guys next time.